Okay, so a few things to notice for this is this would be like your parent population, okay? This would be the population as a whole, and you're trying to take a sample of it. So one thing I was doing quickly was trying to say, let's say I had n is 5 or n is 25. If I go by picking 5 people at a time, what you should notice is I should start resembling where my curve should be normally distributed, or normal distribution. And you can tell that more and more as I keep clicking on this. Now obviously I'm going by 5s. So one quick way to jump to it is by clicking 10,000, but I'm going to click 5s. And you should be able to notice that this is that where you have the smaller sample, okay, you're going to have more variability. That means my standard deviation is going to be greater, and I'm going to get more numbers lower and a few numbers higher, whereas this is my sample size of 25, where I keep picking numbers 25 at a time and calculating the mean of them. And notice how this is smaller and my standard deviation is smaller. But as I keep going through, I'm picking, for this one I'm picking groups of 5, this one I'm picking groups of 25, and the means are being recorded in here. And you can see slowly but surely they're starting to resemble the a standard distribution or a normal distribution. And right as you can see now that I've got about means of about 700 samples, then you can kind of tell that. If I were to, I can clear this and do a skewed distribution and start the same process. Now notice again, when I'm choosing 5 at a time, my variability is large. And when I'm choosing 25, I have a smaller standard deviation and I have a smaller variability. Now right off the bat, this one is looking more normally distributed, and this one is getting there, but not there yet. I'm going to give you a link so that you can play around with this as well. The basic idea of the central limit theorem is that you really should have an n of 30 or more to be able to assume that it's going to be normally distributed, or a normal curve. So, and see how as I'm getting greater, of course, they're both looking normally distributed. But the idea is that the central limit theorem says if you have about 25 is good, but we're going to stick to about 30 or more that you're picking from at a time. Your n is 30 or more, then you can assume it's going to be a normal distribution. Anything lower than that, and you can't really tell because you're going to get this big data that's going to be, it's going to have a larger variability. And so the actual graph may not look like that. Now notice to combat that, the more and more samples I'm taking, or the number of times I'm doing that sample over and over and over, of course I'm getting more of a normal distribution. So we talked about that before, about I think it was n times p has to be greater than 10, I think was the formula that we followed. And that was that if your probability was very small, you wanted to have a large n to kind of counteract that. Same kind of idea, but central limit theorem, and I'll skip to 10,000, and you can do 10,000s based on that. I might even be able to custom it. So you can tell that if you have a smaller n, you can't really tell what type of shape this is. The larger the n, you can tell the more the shape that it's going to become. And that's what the central limit theorem means.